All right, I believe just about everyone in this room plays some role in the state water planning process. These planning cycles are continuous, and with each round we encounter new considerations and valuable lessons. Our first speaker today, Andy Donnelly, has been involved in both joint groundwater planning and regional water planning. As the senior hydrogeologist at Advanced Groundwater Solutions, Andy will share his insights on how joint groundwater planning integrates with regional water planning. Please join me in welcoming him to the stage. And the green button is for advancing.
The green button's for advancing, all right. Okay, good morning. I'm putting on a little bit of a different hat today. I've been involved with joint groundwater planning for 15 to 20 years since I was at the board back from 2005 to 2008. So I know joint groundwater planning very well. Recently, I've been getting more involved with the groundwater side of regional water planning and run into some issues. And I thought that it would be a good idea to get up here and let everyone know some of the things to think about during the joint groundwater planning that everyone is currently involved in, and maybe be able to solve some of the things that I'm running into. This is a chart we put up showing that we have two different water planning cycles that go on simultaneously. We have joint groundwater planning, which everyone here is involved with, where the GMAs work and adopt DFCs. They send those to the Water Development Board. The Water Development Board provides estimates of MAGs. Those go back to the GMAs, and that cycle continues on. It's on a 5-year cycle. At the same time, we have the regional water planning cycle. The MAGs that are developed in joint groundwater planning are sent over to the regional water planning groups. They use those MAGs and develop regional water plans, including strategies. Those are sent to the board. The Water Development Board combines those into a state water plan, and they provide funding for those strategies to make the strategies into real projects. The state water plan is sent back, so to speak, to the GMAs, and that information in the state water plan is one of the factors that has to be evaluated by the GMAs during the development of the next DFCs. They have to look at the needs and strategies. So if we're going to talk about regional water planning, I kind of want to talk about a couple of the basics. It's important to remember regional water planning really focuses on the details. They look at aquifer, county, basin splits for everything. As with joint groundwater planning, it's on a 50-year planning horizon, and they look at evaluations of data for every decade. When I was going through this talk, I kind of was trying to figure out how to put the terms in order. This is what I ended up coming up with for some of the basic things that I'll be talking about during the talk. When we talk about availability, that is the maximum amount of raw water that can be produced from a water source during drought conditions. A water source might be an aquifer, it might be a reservoir, but that's what availability is, and we'll get into that in a little more in a second. Supply, or an existing supply, is the maximum amount of water that is currently legally and physically available for use by a user during drought conditions. For groundwater, that's going to be permits in hand, and it's going to be existing wells and infrastructure. How much a user can produce right now. Users, you'll commonly see the acronym WUG. I like that acronym, Water User Groups. That's who regional water planning, that's who is planned for. Demand. Demand is the projected volume of water that is required by a WUG in a drought year condition. The initial, I think, year and a half of the regional water planning cycle, I believe, is spent firming up population and demand projections. These are the numbers that they're going to be basing the planning on. A water need is a potential water supply shortage. It's basically the difference between your current supply and what your projected demand is. If you have a supply that's greater than your demand, you're okay, you have a surplus. But if you have a demand that is greater than your supply, you have a need. And then there are water management strategies, and these are plans that are developed by the regional water planning groups to address projected needs for a WUG or WUGs. And importantly, strategies can be either recommended or alternative. Recommended strategies are the ones that are eligible for SWIFT funding, the State Water Implementation Fund for Texas. That's one of the big funding sources for water projects. So we'll get into availability a little bit more. Groundwater availability is both MAG and what we call non-MAG. The MAGs are the modeled available groundwater. Those are calculated by the Texas Water Development Board based on the desired future conditions that are adopted by the GMAs. And as you can see on Bastrop County, there is an example I pulled up. A MAG is basically just an accounting of all of the pumping that is in the model, and it's just divided up based on where that pumping is located, based on where the model cell is. So for Bastrop County, most of the pumping in this particular aquifer is going to be assigned to the Colorado Basin. There's going to be a little bit up there in the north in the Brazos Basin and one cell down in the south in the Guadalupe Basin. And that's basically how it works. They're providing us a MAG for each aquifer in each county basin, and that goes over the water planning groups. Importantly, the Water Development Board also provides non-MAG availabilities to the regional water planning groups for aquifer county basins. So even those areas where we're not developing DFCs and there are no MAGs, there are still availabilities. The MAGs are required to be used as the availability for the source by the regional water planning groups. There is the ability for the regional planning groups to adjust the non-MAG availabilities. And importantly, existing supplies, what we say a user can currently produce, and recommended strategies, which is water that we're going to be planning for in the future, they cannot produce water that is not available. So the availability is kind of a cap to what the supplies and the strategies are able to use. So when the board gets done compiling all of their availabilities, they send out this chart. I'm not going to go through all this, my goodness. But it's, I think, 1,100 aquifer county basin splits, about 2/3 of which are MAG and about 1/3 of which are non-MAG. So we'll get this big spreadsheet. You can see there's a column in there that's for planning groups, so I can filter it out to work on whatever particular region I'm working on at the moment. And also, probably can't see it, but at the bottom there are the tabs, and there's data from the previous planning cycle from 2022 and for the current planning cycle. So what's the first thing that we do when we get this? We want to sit down and look and see what changes have occurred in our groundwater availability and compare them to the previous cycle. If the groundwater availability has remained the same or has increased, we know that what was done in the previous regional water planning cycle is not going to be impacted. There's plenty of work to be done moving forward, looking at the new supplies, the new demands, the new availabilities. But if we see that the groundwater availability has decreased, we need to kind of look at what impacts those are going to have on the previous regional water plan. That's currently what's in the state water plan, and we needed to have an idea of how those impacts are affecting. So here's an example. This is Region G. Lots of groundwater in Region G. We have 6 major aquifers. We got about a dozen minor aquifers. I'm not going to go through all these numbers. This is basically just showing the availability by decade in each one of these aquifers. At the bottom, we can see that Region G has between 800,000 and 900,000 acre feet per year of available groundwater now. In the last planning cycle, it was 767 to 793,000. So it's gone up quite a bit. But that doesn't really tell the whole picture. We want to look at each aquifer kind of individually. And if we look at each aquifer individually, I've highlighted in bold and red where the availabilities have gone down. So we see that those increases for the region as a whole are driven by the majors, in particular the Carrizo-Wilcox and the Gulf Coast. And most of the minors have remained the same, but there are a handful of minors that are showing some good-sized decreases. But even that doesn't tell the whole picture. Remember, we need to look at the details. So we look at the Carrizo, which has an increase of 27 to 93,000 acre feet per year, and we break that down on a county basin basis, what you'll see is that 4 of those county basins account for pretty much all of that increase, mainly in Burleson and Robertson counties, to a lesser degree in Lee and Milam counties. At the same time, we've got 3 of those county basins which are showing decreases. In particular, Falls and Limestone County, which are showing some pretty big decreases. That's my first example, so we'll get into that in just a minute. So what are some of the issues? I tried to sort out and describe the issues that I've run into and put them into broad categories. What I came up with are areas without groundwater districts, non-relevant areas, the ones that are generating the non-mags, and then just kind of a general category on models and GAMs, because those have obviously a significant impact on the process. So we'll start off on areas without groundwater districts. I think every one of the GMAs in the state has at least some area within the GMA that is not represented by a groundwater district. They don't have a voice on the GMA, but more importantly, there may not be anybody in those areas that are at the GMA meetings that have a good understanding of what's going on in that area. There may be somebody from a particular utility that was told to go to the GMA meeting and they know what is going on with that utility. They may not know everything else that's going on in the area. So there's not somebody with an expertise in those unrepresented areas present at the meetings. So the example I have is from GMA 12. GMA 12 is made up of 5 different districts: Mideast, Texas, Brazos Valley, Post Oak, Savannah, Lost Pines, and Fayette County. There's not a lot of unrepresented area in GMA 12. We've got the eastern corners of Navarro, Falls, and Williamson County, and about the eastern third of Limestone County. And to let everyone know what GMA 12 is all about, the Carrizo-Wilcox, in particular, the Simsboro, and to a lesser degree the Carrizo, are the big producing aquifers. There are other aquifers, but those are the big ones. And there are hundreds of thousands of acre feet that are being modeled and included in the GAM. So it's a lot of water. What happened when we are all done with the last round of planning, the final well file for the mag run had significantly less pumping in Limestone County than the previous round. Because of that, the mag was reduced. So the mag and the pumping in the mag that was in Limestone County was 11 to 12,000 acre feet per year. And that was reduced to 955 to 1,415 acre feet per year. So that's like a 92 or 93% decrease in pumping and decrease in the mag. I have ideas on why that might have happened. I haven't looked into it in detail, but that's really not important. The important part is no one caught it. It fell through the cracks. To put it in context, Limestone County has had a historic pumping of about 4,000 acre feet per year, and that's gone on since the 1980s. About half of that pumping is by 7 public water supply utilities. They've been pumping it. They're going to continue to pump it. The water levels, it's not like the aquifers going down and they're in dire straits. The water is going to continue to be pumped. What does this mean? Well, here's a table I put together. I realize that there's lots of numbers. I'll try and describe what we have. The top line shows those previous availabilities, which were 11 to 12,000 acre feet per year. And the updated availabilities on the next line, which is now 955 to 1,415 acre feet per year. Remember that the assigned supplies, what we say the existing WUGs, the water users, can currently produce, was based on those previous numbers, which were 11 to 12,000. So we have 6,459 acre feet per year of assigned supplies for the users in Limestone County. But now we have availabilities that are 955 to 1,415. So we're going to have to reduce those assigned supplies significantly to get them underneath that new availability. So we're going to have to, in 2030, reduce those supplies by about 85%. So the municipal utilities that I mentioned that are producing about half of the 4,000 acre feet per year, they have a supply of about 2,287 acre feet, which is realistic. That's pretty close. It's going to be about 350 acre feet per year in regional water planning for the next cycle, which is not realistic. And if we have assigned all of that availability to those supplies, What that means is there's no more water left for strategies. So we currently have 5 recommended strategies in Limestone County that use Carrizo-Wilcox groundwater as a source. And those recommended strategies are going to have to now, I believe, be alternative strategies because there's no water left over for them. You can't have a recommended strategy that doesn't have available groundwater. That means that those 5 strategies are now not going to be eligible for SWIFT funding. To be clear, there are other funding mechanisms that those projects might go after, but the SWIFT funding is one of the big ones. So the result of this is just going to be making it harder for these particular projects to obtain funding. So what have we got in Limestone County? We've got reduced supplies, which is leading to increased needs. Remember, needs are the difference between the supplies and the demands. Demands aren't changing. Our supplies are going down a lot, and so we're increasing the needs. At the same time, what do we do when we have needs? We plan, we develop strategies to meet those needs, but we have no more groundwater left. So the 5 strategies that were in there using the Carrizo-Wilcox Act for groundwater are no longer going to be recommended, and we don't have the ability of developing other strategies using groundwater. How are we going to address this? We're probably going to have unmet needs where you have identified a need and you've not been able to develop a strategy to meet those needs, including unmet municipal needs. And as you can imagine, try to avoid having unmet municipal needs. Sometimes they're necessary, but you try to always meet those municipal needs. Hopefully, GMA 12 will address this in the next round of joint groundwater planning that's currently underway and get pumping. The pumping's happening in Limestone County. It's going to continue to happen. So we need to make sure that that's in there so that we can avoid this problem. And also note that the next regional water plan, the one that we're working on right now, it's not going to accurately reflect Limestone County. 5 years from now, when GMA 12 is looking at recommended strategies and needs as part of their the second factor, they're going to say there's no recommended needs for Limestone County. I mean, no recommended strategies for Limestone County. There should be. There were 5, but we've had to make those alternative strategies rather than recommended. Likewise, the needs that are going to be generated right now are going to be much higher than they need to be. Next topic is going to be non-relevant areas and aquifers. I think a lot of people who are involved in joint groundwater planning know GMA's had the ability of declaring parts of aquifers, so on, non-relevant for the purposes of joint groundwater planning. In those areas, DFCs are not developed, not adopted, and MAGs are not calculated. And after GMAs declare areas not relevant, they just tend to not focus on them a whole lot. Of course they don't, they're not relevant. But remember that all areas are relevant for regional water planning. And even though an area may be non-relevant, there are non-MAG availabilities that the Water Development Board will develop and will forward to the regional water planning groups for use in regional water planning. Non-MAG availabilities are often calculated by the board based on MAG runs. So if you have parts of an aquifer which are relevant and other parts that are not relevant, like we're seeing here, this is from the last round, and you can see the purple for the Dockham aquifer. We have parts of that aquifer that are relevant and parts that are not relevant. The model is going to cover that entire area. And the pumping that's included in those models are used as the non-MAG availabilities. And sometimes, because the focus is on the relevant part, insufficient pumping is included in the model in those non-relevant portions. In some cases, we're finding that there's no pumpage included. And these non-MAG availabilities will come back in that big spreadsheet that I showed you that said, with the following comment, TWDB modeling note, these are non-relevant DFC compatible modeled pumping values. So basically the non-relevant, the non-MAG is being tied back to the DFC. I think they're worried about the possibility of regional water planning groups coming in, putting a lot of pumpage into a non-relevant area. and impacting the DFCs. So that's reasonable. What I just found is that this issue of compatibility extends between GMAs. So Brazos River alluvium in Falls County, which Brazos River alluvium was designated as non-relevant by GMA 8 entirely, previously had an availability of almost 17,000 acre-feet per year. The availability that we got back was 0. And we have an historic use of about 8,000 assigned supplies, about 8,700 acre-feet per year. And the availabilities came back with the modeling note, TWDB not modeling note, non-relevant and not modeled for GMA 8. If planning wants to add values to this GMA 8 split during technical memo review, please check GMA 12 model results for this area before approving. So we've got the possibility that what's going on in GMA 8 might impact what's going on in GMA 12. This was not on my radar at all, so it's one of the reasons I wanted to get up and kind of communicate to those people who were doing the planning to be aware that these are some of the issues that could come up with this. The last category is kind of just talking about model considerations. As we all know, the GAMs play an important role in joint groundwater planning. The GAMs are living tools and they're constantly being updated. And it's important to remember that sometimes the updates can be fairly significant and they can have significant impacts on availability. So especially when you have a new model, you may find that in some cases the availabilities might go way up, in some cases they might go down. And here's an example from Region I and GMA 11. And this is the Carrizo-Wilcox Aquifer, which did have a new model introduced during the last joint groundwater planning cycle. And again, with the differences between the middle column, which is the previous availability, and the current availability in the column to its right, the difference is in the far right column, and you can see that a lot of those are red because the availabilities have gone down. One of the reasons I wanted to include this is to show that, yeah, we've got availabilities that have gone down. That's not all bad. This isn't like the sky is falling. In many cases, most of the current availabilities in the model are above historic pumping. More than half of those total availabilities are above the assigned supplies, and the ones that are not above the assigned supplies are not tremendously above the availability, so we're not going to have an 85% reduction like we did with Limestone County. There are a couple of places where there are strategies that may be impacted, but if we wanted to tackle, how might we fix this? And it's not a problem. This is what the model is providing us. So it's not like there was an error or an oversight. This is just where the model ended up. But if we wanted to focus on it, there would probably only be 2 or 3 or 4 places in here that we'd want to look at and see what we could do to increase availability if possible. And finally, there may be other model issues that come up. I can't pretend to think that I can come up with or understand all of the implications that models might have on the process. You never know what's going to happen. Here's one that happened last cycle, which was unusual. I think it caught everyone off guard, where we had pumping in Cameron County, and about 2/3 to 3/4 of the county was not included in the MAG. And the reason for that was the official footprint of the Gulf Coast Aquifer. When the TWDB is evaluating the DFCs and looking at the MAGs, they might come up with issues. They might find some things that they have questions about, and they might ask the GMA for clarification. If the TWDB comes back and asks you as a GMA for clarification of something, be sure to engage them. Make sure you find out what the issue is, because it may be something that causes issues down the line. So the takeaways from the talk, when the GMAs are done with their modeling, and do kind of a post audit, look at what the availabilities are with respect to what they were before. Not saying the availabilities can't go down. In a lot of cases they will. In a lot of cases they're not a problem, but we just want to make sure there are no surprises. Places where the availabilities are going to cause problems for regional water planning moving forward. Watch out for those unrepresented areas. There may not be anybody involved in joint groundwater planning that are that know what's going on in those areas, so pay attention to those. Pay attention to getting appropriate pumping into non-relevant areas if you're doing a model run for those, including identifying aquifers where coordination between GMAs may be needed. There's not many, but there's a few. The TWDB comes back and asks you for clarification on something. Make sure you figure out what they're talking about, because it may be something that you can address during the final stages of the joint groundwater planning process, and it doesn't get carried over and finalized and then sent to the regional water planning groups. And importantly, remember that GMA actions in joint groundwater planning, it has potential to impact regional water planning and very importantly can impact water users. If we've got strategies that are out there that are recommended that are having to be shifted to alternative strategies, that can potentially impact water users in being able to take projects, plans for projects, and make them into real projects. And that's all I have right now, right on half an hour.
All right, I think Justin's got one question, and we did have one come in on the app, so I'll let Justin go.
You know me, I've always got a question, right? So, I mean, your talk is about, joint planning and how it ripples into regional water planning. I didn't hear you mention anything at all about, well, I'll back up a step. So, regional water planning is obviously all couched within the context of drought of record conditions, right? But DFCs and MAGs are obviously sort of business as usual conditions. Do you have any thoughts on the implementation of the new sort of GAM MAG peak factor, right, that attempts to address drought conditions and pumping?
Yeah, the peak factor has been around for a few years. I believe there were only 2 peak factors that were used the last round of planning. I mean, when I first heard about it, I didn't really understand. I think that was the case with a lot of people, and they kind of got worked up in what's this peak factor. It's basically addressing the baseline differences between what we're dealing with in joint groundwater planning and regional water planning. Regional water planning is all focused around drought conditions. What can we do during drought? Whereas a lot of what joint groundwater planning is looking at, we look at average conditions. We're looking at predictive runs. We don't incorporate drought in there. It's all average. And as we know with when you have a drought in groundwater, you pump more. Water levels go down. When the drought ends, pumping decreases and water levels go back up. So the whole concept of the peak factor is being able to incorporate in the focus on drought with the average conditions. And it makes sense. The concept makes perfect sense. Yes, you can pump 1.2 times your MAG during a drought, knowing that in subsequent years it may be back. So the concept is sound. I mean, it makes sense. It's just not being used a whole lot. I'm not sure how many GMAs are considering using it for this round. I know that one of the 2, which was used in the last round of joint groundwater planning, is not planning on being used this round. But whether there are any new ones, I don't know.
Yeah. I mean, to me, it just makes a lot of sense, right, to account for the reality, right, that groundwater pumping goes up during a drought period. And I personally could see a more widespread implementation of this peak factor having fairly significant consequences to the regional water planning process, right, when you're looking at groundwater availability and how that might change significantly in some places, right, under a peak factor. So it's just kind of a thought. I just wondered what your thoughts were. So
yeah, I mean, the peak factor makes sense. I mean, I don't disagree with this logic, but it's just not being used very much.
We'll see what happens in the future then. Thank you.
Yeah, we'll see.
Okay, we have time for one more question. Sorry, Ron, he was here first. So.
All right.
Unfortunately.
Wait, which Ron?
Catch him during the break.
Hey, Andy, can you just expand a little bit on what opportunities there are or limitations to SWIFT funding in white areas, those areas not represented by a GCD?
I'm getting into regional water planning, and I'm not the best, but I mean, it's not relevant whether or not the areas are in a represented or unrepresented area within the GMA. The GMA, the joint groundwater planning, is only firming up the availability aspect that's then transferred over to the regional water planning groups. Once it's in regional water planning, they're planning for everybody. So regardless of whether or not those areas are represented or not within the GMA, they are a part of the state, they are being planned for, and if needs are identified in those areas, they are making plans to address those needs, regardless of whether there's a district there or not. So they're as equally able to get strategies in the plan and funding from the Water Development Board, SWIFT funding, or any other funding as any area that's within a GMA that is represented by district.
Thanks.
Okay.